Alright, draft science physics type video. Holiday has made a question. So we're still back on the subject of this relativity issue, and they're not being able to understand the idea of two velocities. I've made so many analogies and comparisons, I don't know why they can't follow along. So he wants me to draw pictures. Well, we're back to, if I animate it and you get what I say, then will that end the argument? Anyway, alright, so this is what they say happens. Spaceship's moving half the speed of light. This is just a reference to time. So this will move as time moves. Hole in the side of the ship, light is shot out. So there's a little photon. There's the first one. So time passes, the ship moves a little bit, time has passed a little, and now there's two photons, and they're lined up nice and perpendicular, and they're going to go straight across the ship. And because they're moving, the emitter's moving, the ship is moving, the hole's moving, and the photons are moving this way. Oh yeah, of course they're going the speed of light across the ship, but they're also moving this way, because photon number 1 was emitted in a different place than photon number 2. You can sort of get that, right? Photon number 1 was heading, let's call this Earth. It's heading for Earth. And photon number 2, because the spaceship moved, is now heading for, like if you look through this hole, you'd see Mars. And then by the time we get here, the third photon, this little fella here, he was shot at Jupiter. But, Earth is way back here now. See? So now you look out the hole. If you want to see Earth, you have to look back here. But you want to see Jupiter, yeah, you'll see Jupiter. And all the 3 photons are heading for Jupiter now. And then all 4 photons will all be heading for, yeah, that's right, Saturn. See, time is passing. They're all lined up. So all these photons all have a momentum going this way, like a baseball. So if I was to stop this ship, if I put a brick wall in front of it, we'll see here, I'll let it go through the hole too. So now we got Uranus or something out here, or Neptune. Well, whatever. Neptune, let's just say Uranus. Yeah, the Earth is way back here now. So if the light had gone true perpendicular, this is where it should be. But didn't go truly perpendicular. Each photon has the momentum of the ship. So yeah, they're all moving the same speed as the emitter. So they all have this velocity, like a baseball inside of a bus or something, plus this velocity. So they're going the speed of light this way, and they're going half the speed of light this way. Now, the truth, and that's a truth, because this photon, when it comes out, he was heading for the Earth when he left. So there's photon number 1. He was heading for the Earth, and now he's heading for Neptune. And in a week, he'll be heading for Pluto. Even though he was heading for one thing, now he's heading for a different thing every day. And as time passes and he travels, he's going to keep heading for something different. Because perpendicular doesn't mean anything. Because it's not moving perpendicular. It's moving at an angle, and it's a theta, and it goes forever. And so it's moving that away. It's not moving that away. Anyway, so if I stop this ship, if I just said stop ship, by their theory, since all these photons aren't connected to the ship, just like a baseball, if I put it on the seat of the bus and the bus hits a tree, the baseball flies off the seat of the bus. Well, by their theory, if I stop this ship or I crash it, all these photons will go shooting this way, because they're still going half the speed of light this way. They somehow have momentum. And so if I cut the top of the ship off, and then I stop the ship, the photons will shoot out this way. So they'll be going the speed of light this way and that way, and you'll be able to see it. I mean, it's the same difference. I mean, they're not hitting anything. Once they leave the emitter, they don't hit the hole, they don't hit anything. So it's the same thing they're going to do when they go outside the ship. But you just see it. It'd be so obvious if I stop the ship, you'll just see all the photons going that way, plus the speed of light this way. So they're going half the speed of light this way, plus the speed of light that way. I'm saying that's paradoxical. That's nonsense. Okay. So this is what really happens. Okay, same timing thing. So the first photon leaves, you see through the hole, Earth is perpendicular to the ship. So the first photon leaves, and it's going to go straight. And so it's going straight. It's heading for Earth. This Earth is now moved. And now if you look out the hole, you see Mars. And that's where this photon's going to go, because the emitter's moving. And then the emitter moves some more. This photon's going to Earth. This photon's going to Mars. Now this photon will end up going to Saturn. None of them are going to get through that hole, though. So none of them are actually going to go anywhere, because none of them are heading for the hole, as you can see. They're all heading straight. They're all going perpendicular at a right angle to the ship. They're all going straight, one direction, the speed of light. One direction, not two directions, one direction, the speed of light. And so on and so on. But the point is this photon will hit Earth. This photon will hit Mars. This photon will hit Saturn. This photon will hit Jupiter. And this photon will hit Neptune. Because they're all moving in straight lines. And they all move, they all go where they go when they were first launched. They don't go two directions. And both observers will see the same thing. A guy in the ship and a guy outside the ship are both going to see the photon crash into the wall of behind the hole. So there's no contradictions, no paradoxes, no mumbo jumbo, no nonsense. So, like I said, I can't analogize it any other way than to say, see, the funny part is if I stop the ship, these photons will make it to the hole then. Because, yeah, the ship's not moving out of the way. I mean, I used the bullet analogy with two steel plates. I've done all I can do to explain this to you. So I don't understand why you need more. So anyway, so I gave you the analogy of now let's just put two holes in the ship, or make it out of glass, I don't care. But two holes, just for simplicity. And this beam shoots always to the same spot. It shoots here and it shoots to Earth, let's say. And it shoots in a straight line. And the ship goes through that beam. So what happens? Well, the ship moves into the beam, no photons get through now. So there's, the photons that were already on their way continue on their way, but there's no new photons coming out. And that's it. Nothing else is happening. These just bounce off. And the hole shows up. So the ship moves a little further, and now the hole is there where the photon is, so a photon gets in. Okay, so now he's inside the ship. Now we know this beam is a straight line. We know it's not going to change because the ship showed up. So we know this photon's going to keep heading for Earth like all the other photons. And this hole's going to move, this hole's going to move, and the photon's not. It's heading for Earth. It's heading in a straight line. It's going one direction, the speed of light. It isn't going to change its motion any. So it's obviously, you can already tell, it's going to have a problem getting to that hole. So the hole's moving the wrong way. And obviously that's what happens. Okay, so now the no more photons. There's just the one photon. He crashes into the wall back here. There's obviously no photons coming to Earth. So Earth is in a blackout. And then the photons start progressively adding up again. So the only thing that's a little bit funny about this circumstance is the observer from Earth, let's say, doesn't see the shadow for quite a while. It doesn't see that this thing went by until quite a ways after it did, in the sense that the light doesn't turn back on, and it doesn't turn off immediately. So it always finds out a little bit late. It has to wait for the speed of light to send the information. See, there's information here in the sense that this got shadowed, this got blocked, and it takes a while for that information to get to the Earth. But no one's going to argue. Are any of you people going to argue that this isn't what is going to happen? You're not going to argue that the photon gets to the hole and somehow goes forward with the ship and goes forward with the ship to come out of this hole. because that would be obvious. It'd be obvious how you bent the light. You bent the beam just by having a hole in the ship. You bent it. And then you're going to somehow bend it to get the hell out of there straight again. I don't know. But you obviously are bending it. So there's no... This is the reality. This is what would happen. There's no... let's do the animation. Yeah, see, it's animated. Crash. Yeah, no mystery. So, yeah, light isn't a baseball. It can't carry the momentum of the school bus. And it's obvious. Like I said, if you stop the school bus really quick, you'll notice the baseball keeps going because it has the momentum of the bus. So if I throw the baseball or I poke it with my finger, it's going to have the momentum of the bus in one direction, and it's going to have the momentum of my poke in the other direction, and it's going to move some vector in the end, a parabola actually, because it has to combine the two. That's what the matter does. It combines the two. Photons don't have a mechanism for that. I mean, I've explained that, how electrons are sort of built and how they're able to do the three-dimensional thing. And this thing, photon, can't do that. Photon does one thing. Speed of light, one direction. It's a one-dimensional object. That's what forces are made out of. Things that have one-dimensional objects. That's what virtual photons are. They're one-dimensional objects. They don't move two velocities. They move one velocity in one direction. Alright, well, hopefully that helps. I mean, I'll just point out again, this is what really happens. Ship's going half the speed of light, the photons leave, and they keep going straight across perpendicularly. The emitter keeps moving, keeps depositing new photons ahead of the other photons, not in line with them, ahead of them. It can't deposit new photons in the same location as the old photon because it moved at half the speed of light. How can it move this way to half the speed of light and deposit a photon right behind the one that was way back there? It doesn't make any sense. It can't. This has to be what happens. Alright. So anyway, enough for the video. Look, I mean, this is, like I said, you can believe, if you want to believe time dilation is caused by bent space, it's okay with me. Well, it's not really okay with me, but whatever. And you want to believe gravity is based on bent space, fine. But there's no reason to do this Heisenberg thing. There's no reason to accept this stupid dogmatic statement that you can never tell how fast you're going. Or you can never tell which one of you is moving. I mean, I could have made this a slightly bit more complicated by having two ships pass each other and both of them have these hole things. Because, yeah, you would find out that you can find out who's moving. Because one ship is the ship that's not moving is going to see the light go through the two holes, and the ship that is moving isn't. And that's just the way it is. So all you have to get rid of, all I'm asking you to, I'm not saying, I'm saying don't believe in this stupid relativity theories because they're wrong. But even if you have to believe in them, doesn't mean you have to be dogmatic about this stupid principle they just made up. That somehow, because in our slow speed encounters with the universe, we can't tell who's moving because we don't have any constant to use, because all the constants are moving fast. All the constants, the forces, magnetism and gravity and light, they're all moving the speed of light, so yet they're not really very useful when you're moving really slow at telling you anything, because you can't see the differences. But if you're going half the speed of light, light becomes a really good tool for telling how fast you're going. Okay, so I can't help you any further. I mean, draw it yourself. What can I say?